Hello, we are Nicoletta. Hello, we are Nicoletta, Ilinka, Alexia, and Andrea, and we are from Costache Negruti National College, and we're going to present you the seating arrangements problem.
The statement of the problem. A number of N people have bought seated tickets for a popular film at the local cinema. The cinema theater has N seats, thus they are fully booked. Inside the cinema theater is dark, and when the entrance door opens, people rush inside, picking up a seat at random. After all seats are occupied, what are the chances that nobody picked a seat written on his/her ticket? What is the average number of people sitting on the same seat that is written on their tickets? And the final point, find the probability that exactly M people out of N are sitting on the assigned seat by their tickets.
Brief history of combinatorics. Combinatorics, also called combinatorial mathematics, is the field of mathematics concerned with problems of selection, arrangement, and operation within a finite discrete system. A basic form of combinatorics appeared throughout the ancient world. In the Middle Ages, combinatorics continued to be studied, especially outside Europe. The Indian mathematician Mahavira, around 850, provided formulas for the number of permutations and combinations. During the Renaissance, together with the rest of mathematics and sciences, combinatorics enjoyed rebirth. Works of Pascal, Newton, Bernoulli, and Euler became foundational in the emerging field of modern times. The works of Sylvester, late 19th century, and Percy MATH.en, early 20th century, laid the foundation for enumerative and algebraic combinatorics. In the second half of 20th century, growth of combinatorics led to establishment of dozens of new journals and conferences in the subject. Nowadays, we can see the connections and applications of combinatorics to other fields, ranging from algebra to probability, from functional analysis to number theory, etc.
Right now, we're going to talk about the notion of random variables. In everyday life, we encounter magnitudes that take values, and values change as a result of random factors. For example, the number of boys in 100 newborns, the number of points that appear when throwing a dice, the number of white balls that appear in a draw from an urn, counting balls of various colors, including white balls, peas, and so on. The result is obtained by measuring a physical quantity, the speed of a gas molecules, etc. We are interested in only those sizes that have a finite number of values. Each one of the previous sizes may take different values in various experiments, even if all the conditions remain unchanged in each experiment. Changing values is based on a random factor. This is why we will call these random bets random variables. To know a random variable, we need to firstly understand the values they can take. But knowing these values is far from being enough. As we have seen, every value is taken under the influence of random factors. As a result, some may appear much more frequently than others. The random variable will be much better specified if we also know the probability with each value is taken.
Now we are talking about the first part of the problem, which is after all seats are occupied, what are the chances that nobody picked the seat written on his or her ticket? So the probability of nobody occupying their assigned seat is equivalent to permutation, picked at random because they are chosen in the dark, doesn't have any fixed points. This kind of permutation is called disarrangement. The number of disarrangement is n factorial times sum from k equals 0 to 9 to n times minus 1 to the power of k divided by k factorial. Now the demonstration. So the number of permutation from the set A is n factorial, and for the second set, which is the set of all configuration, where person I sits on seat I. We use the inclusion-exclusion principle. We have an example and an explanation.
Right now we're going to talk about the second point, which is, what is the average number of people sitting on the same seat that is written on their tickets? Let x be the random value related to an experience which takes the values. If we make n times the value x index 1 appeared n index I times, then putting in a conventional order the obtained values, we can say that these values are: the mean of the numbers will be the following, where f index 1 is the relative frequency specific to the value x index I. This observation leads us naturally to the following. Right now is the definition of the random value, and we will call this random value the variable of this number, which is the sum from I equals 1 to n multiplied by p index I times x index I.
For the medium number of fixed points, we made these notations. For m index n, we noted the m index n with medium number and also the sum of probabilities. And for the combinations and k factorial, we have that notations. And we also made the notation for the probability of k fixed points existing. We place n minus 1 factorial times m index n with that equation, and this is the sum of the permutations of n minus 1 degree with k minus 1 fixed points from 1 to n, and that sum, this is the sum of all permutations of degree, resulting n minus 1 factorial times m index n equals n minus 1 factorial. And in conclusion, mn equals 1 and doesn't depend on n.
Find the probability that exactly m people out of n are sitting on the assigned seats by their tickets. The probability that m people can sit on the assigned place equals n fixed points. Explanation, we made a notation for the number of ways the fixed points can be chosen. N minus m factorial equals the number of possible dearrangements for the other n minus m people. The arrangements equal 0 fixed points. Q index m will be in the end equal to 1 divided by m factorial times the sum of n minus m and k starting from 0 times minus 1 at the power of k divided by k factorial. In the end, the sum of n and m starting from 0 times q index m would be equal to 1. And the explanation is shown in the graphic. If n is big, it's more than 20, then the equation would be approximately 1 for n bigger than 5.
That was our presentation. Thank you for watching.
Is there any question in the public? No, we don't. You did a great work. Maybe you can tell us how long are you doing MATH.en.JEANS, like every week, once a week? How many hours?
Once a week. We prepared for the past month more intense, and we've done once a week.
Okay.
All of us.
I've seen, I forget his name, but I've seen that you were working with someone from IASI University.
Yes, Mr. Staleriu, Julian Staleriu.
Okay, and you meet him, is coming at school, or you're going to university sometimes?
He's coming to our school, and he checks on our work.
Okay, you're a lucky group, like we are in Berlin, like researcher coming to school. I don't see any question on the chat, neither. Thank you very much, and then we're gonna have a new group, and hope you'll meet you next year again.
Of course. Thank you.
Cheers.